Hey grade 12s, we're about to move on to trigonometry and talk about general solutions and trig equations, and quite an infamous chapter. I know you guys don't always enjoy this section of work, but hopefully we're going to feel positive at the end of this video and at the end of this exercise. Just to recap what we've done already, without me going back on these notes, but just in Mr. Norman's notes that we've been working through, we've derived and we've worked through the compound angles and double angles. Okay, that's taken us through exercise 1 and quite a long exercise 2. And now we're on this page that you can see on your screen now, where we're going to unpack what equations are all about. And Mr. Norman's given us a few techniques here. I know because of double angles, especially with the cos 2x or cos 2 theta rule, you've got three options, and it's not always clear which one to use. And often it comes with practice, just knowing which one to use. But here are some techniques that he breaks down for us to know which one to use and when. So you'll see in the first example, I've filled in a bit of information that I think I have sent you already. And you'll see in technique 1, you have changed the sine 2x, which is that one over there. Hey? You've changed the sine 2x there into 2 sine x cos x. You've also changed the cos 2x over there into cos squared x minus sine squared x. Okay. Now at this point, you're gonna, and he guides you here on the right. You're going to be able to factorize by grouping, because you've got because you've got 4 terms. 1, 2, 3, 4 terms. You are able to factorize by grouping. You're going to take out 2 sine x from the first 2 terms, leaving you with cos x plus 1. You're going to take out a cos x from the second pair, leaving you with a cos x plus 1. Because there's a common bracket of cos x plus 1, the remainder of 2 sine x plus cos x will form the second bracket. Okay, just old school grouping from back in the day. Right, now we work with both of those brackets. Firstly, 2 sine x would equal negative cos x, that step over there. Right, then if I take this 2 across, I'm going to end up dividing by 2 on the left hand side. Okay, and if I divide the cos x back to the left, I'm going to have sine x over cos x, which we know is tan x, is equal to negative a half. Okay, so you remember, when is tan negative? Tan is negative in the second and the fourth quadrant. So you'd first type and work out your reference angle by saying shift tan a half. Remember, ignore the negative. Let's just make sure my answer is right here. Shift tan a half equals, and you get 26,57. Right, 180 minus 26,57 is taking you into the second quadrant. And plus 180k, because the tan graph is a 180 degree period for it to repeat itself. We need not do the fourth quadrant because it is immediately 180 degrees away from the quadrant we've just done. Okay, so the last step would be to say x is equal to 153, 43 plus 180k, and k is an element of z, being integers. So that's taken care of the left-hand side of our question. The second part is to say cos x plus 1 is equal to 0, making, you see where I am here, making cos x equal to negative 1. In other words, when or what value of x will make cos of x equal to negative 1? And that's 180. Okay, cos of 180 would have given you negative 1. So x is equal to 180 plus 360k in this case, because a cos graph takes 360 degrees to repeat itself. Okay, so we've taken a long sort of question there, lots of stuff. We've factorized it, and we've got our 2 strands of our answer. Okay, technique number 2, he talks about using co-ratios to make functions the same. Okay, instead of having sines and coses, we're going to try eliminate to only have sines or only have coses. Okay, then he says, then equate angles in type sine A is equal to cos B. Okay, we're going to make them equal. Watch carefully here. The first question, or the question in the start, gives us sine x plus root 3 cos x is equal to 2 cos 3x. And I've added there to my notes, divide everything by 2. Okay, which you can do. If you divide everything by 2, you're not changing anything. If you divide left and right hand side by 2, you're fine. Okay, in other words, there was a 1 in the front there. So if I divide it by 2, it's going to give me a half. There was a root 3 in the front of the cos x. That's going to give me root 3 over 2. And there was a 2 over there, which now when I divide by 2, I'm going to just have a 1 left. Okay, so that's how I've gone from my first step into my second step. And you might not realize why you're doing this, but you are hoping to establish a compound angle in action. Okay, so then my half is replaced with a cos 60. My root 3 over 2 is replaced by a sine 60. Okay, then my left-hand side entirely, cos 60 sine x plus sine 60 cos x is a sine compound angle, which makes it sine of 60 plus x. And the right-hand side is still there, cos of 3x. Here's where we're going to have to use co-ratios. Because my left-hand side involves sine and my right-hand side has cos, I want them to be both the same. So the notes here have opted to make the right-hand side also a sine. So cos 3x is the same as saying sine of 90 minus 3x. Okay, there's your co-ratio in action. Notice also that the left-hand side and the right-hand side, as well as being both sines now, they're both positive, right? Both of those trig ratios are positive. So when is sine positive? In the first and the second quadrant. So the first quadrant we're going to answer for and say 60 plus x, which is the left-hand side's angle, must equal 90 minus 3x, which is the right-hand side's angle, plus 360k, because it repeats itself every 360. Now it's just to clean it up. We bring the negative 3x across, and our x becomes a 4x. 90 is then going to be joined by negative 60 to give us 30. Lastly, on the left-hand option, you're going to now divide by 4, making x equal to 7.5 plus 90k. Awesome. However, you've also got this second quadrant to answer for. Therefore, 60 plus x is equal to 180 minus the right side's angle 90 minus 3x plus 360k. Okay, so now we just clean that up. We've got an x on the left already. It's on the right, you're going to have a plus 3x. So when I bring it across minus 3x, I'm going to get negative 2x. On the right-hand side, I've got 180 minus 90, which is 90, minus the 60 from the left is giving me 30 plus 360k. Lastly, divide by the negative 2. I'm going to have x equals negative 15 minus 180k. And I've said here that minus 180k, it doesn't matter if it's a minus or a plus, because you are going to substitute in for the value of k. So it doesn't really matter about that negative or positive over there. And there's your answer. General solutions, remember specific solutions, you would then substitute values into k over there or k over there perhaps, and see what answers pop out and whether they fit into an interval that you're given. Okay, so technique 2, hopefully co-ratios there, you can understand how they went about business there. Technique number 3, use identities to simplify before we factorize. Now here's where this double angle is going to come into play. Okay, so the question is 3 sine squared 3x minus 8 sine 3x minus 3 is equal to cos 6x. Now you should be able to see that the left hand side's angle is 3x, but the right hand side is 6x. So that's where I've written on the right here. Cos 6x is the same as saying cos 2 times 3x. So there's your double angle. It's like saying cos 2 theta, but instead of theta, you've got 3x. So we are going to be able to use our double angle identity here, but just to choose which one is the trick. If my left-hand side only has sines in it, I'm going to take my right-hand side, cos of 6x, and make it 1 minus 2 sine squared 3x. Remember, one of our identities was cos 2 theta equals 1 minus 2 sine squared theta. That is what we are using here. Instead of theta, though, we've got 3x. Okay, so that's how we went from there to there. Right, now we've got only sines. So if I bring the right-hand side over to the left-hand side and make it equal to 0, I'm going to get 5 sine squared 3x minus 8 sine 3x minus 4. That we are going to now use quadratic trinomial and factorize it. 5 sine 3x plus 2 and sine 3x minus 2. Okay, you can FOIL that out to make sure you did it correctly, but yeah, that's right. If I just want to address the right-hand bracket first, sine 3x would then have to equal 2. And the answer there is no solution. Remember, the amplitude, there's a 1 in front of the sine. That means it's only going to reach a height of 1 and a low point of -1. So it would never reach a height of 2. So you can stop with that side of the story and write no solution. The left-hand bracket over there, though, there's more work for us to do. 5 sine 3x plus 2 would mean that sine 3x is equal to -2 over 5, right? That makes the sine negative. The sine graph negative. When is the sine graph negative? 3 and 4. So we're first going to work out our reference angle by saying shift sine 2 over 5. Do not type in the negative, okay? The reference angle, therefore, gives you 23,58. So we are going into the third quadrant, and we therefore say 3x, our angle in this case, is 180 plus 23,58, our reference, plus 360k. Clean this up. 180 plus 23-ish is 203. And lastly, divide by the 3, making x equals 67,86 plus 120k. Cool. So that's taken care of the third quadrant. The fourth quadrant makes 3x equal to 360 minus 23,58. We're going into the fourth quadrant, plus 360k. Firstly, minus the 23,58, giving us 336,42. Divide by the 3, and there is my general solution for the right-hand side of this bracket. Okay, or the other side. Okay, so that's technique 3. I'm going to pause this video or stop this video, and I'll mark exercise 3 in the next video. Hopefully that helps, gents.